Awesome. For folks that have joined in early, great to see all the excitement here. And we're going to get started very, very shortly. So we're just going to give a couple more minutes for folks to come in. We already have a lot of folks in, and we'll get started very shortly. So stay tuned. All right. Hi, everyone. Welcome to the LinkedIn Live with Manjunath Bhat. So it's a super exciting day for all of us here. We've got some very exciting things coming up. So we're going to give just about 30 seconds more as we see. I see a lot of people starting to roll in. So we're just going to give about 30 seconds more for folks to roll in, and then we'll get started. Okay, awesome. Let's actually get the show on the road. I'm just gonna put a comment for everyone on the live to go ahead and refresh your screen in case you're on the live page to start seeing the live kind of go through. All right, let's get us started. Awesome. So let me start and introduce our guest for the day. He's someone very very special, and I know a lot of folks actually pay a lot of money to hear Mr. Manjunath Bhat speak on some of what's the latest that's happening in software technology and engineering. He's an expert who's a research vice president at Gartner, and he's been covering everything from DevOps, GitOps, DevSecOps, so any form of ops, but also a core specialist on the software engineering side. Like I mentioned, he has now over 5 patents that have been granted, and he was one of the folks behind and the core person responsible for the technical architecture and warehouse automation software for one of the world's biggest warehouses in North America. Also, head of engineering at AirWatch by VMware, and done some phenomenal things in his journey. So it's going to be an absolute pleasure as he covers some amazing areas of how do we talk about what's happening, the latest trends that are happening in software engineering, and what to look out for to build great, amazing, game-changing software. A quick intro about myself. Hi, everyone. For those that don't know me, I'm Abhinav, one of the founders at Fluid AI. and we work on the cutting edge of conversational AI to help organizations scale by leveraging conversational AI by improving their revenues, reducing their costs without actually hiring any people. So without further ado, let's get our guest on, and I'm going to go ahead and welcome him on. Hi Manjunath, how are you doing?
I'm doing good, Abhinav. Thanks for hosting me. And I think we've known each other for quite a few years now, and we share a common passion for everything from like machine learning to software engineering. I've been to your office, right? I've seen how you hire people, how you groom your teams. So I think this sort of common thread for love of software engineering and building teams and building companies is, I think, what got us here. So thanks. I think I'm looking forward to this chat.
No, absolutely. I think we've been really looking forward to this for quite some time now. So super excited to have you on. And there's so much changing, right? I think you might have seen this as well in the whole software space. Do you get a lot of questions from software tech leaders to CTOs, CIOs, heads, and developers around what am I doing wrong, right? Because I
Yeah.
think with COVID, there was this one big change of working from home and working more asynchronously. But apart from that, I think there's just so much happening in software. Do you get
Yes.
a lot of these questions?
Yeah, I mean it's funny you mentioned that, like, because I've been a practitioner myself, right? The big change I see after having joined Gartner is that you have a much broader perspective. Like, in fact, let me if I can actually share a slide that might be helpful even for our audience. So see if you
Oh,
can
wow.
bring it on, right?
I'll have to
Yeah,
see.
so
Yeah.
so right here.
Yeah.
So one big shift, Abhinav, what we've seen, especially since you mentioned, with COVID, people working remotely, there is actually even now big concern around developer productivity, right? And one
Yeah.
of the things we've seen at Gartner is how you can flip the conversation from focusing on developer productivity to developer experience. Because in many
Mhm.
ways, I'll make a pretty bold statement, and even to some extent provocative, if you're managing teams. So developer productivity, measuring developer productivity per se is a misnomer, because if you think about it, developers do not produce, right? The whole idea of productivity would mean that you're really focusing on what they produce. But
Mm.
essentially, it's if you look at how great companies are built, how great software is produced, we're looking at software engineers as creators, right? Developers are creators. Developers solve problems. They support operations and so on. So none of these things are actually done at a velocity that can be measured at the level of an individual developer, right? So the whole idea of just focusing on individual productivity, that's actually harmful for the organization. And in many ways, like, this was an epiphany for me, like, for a few days back when I started to hear a lot about quiet quitting, right? If you
Mm-hmm.
look at what you're seeing on the slide here, right, we focus a lot on, let's say, improving developer journeys, trying to make them productive as soon as possible, right? That as soon as you hire people. But
Mm-hmm.
what leads to quiet quitting, by the way, is if you distract yourself from the other two pillars. Like, for instance, you might love this because your whole company is built around creative potential, right? So if we
Yep.
don't let developers optimize their workflows for creative work, that's when they get sort of disenchanted. They're disengaged. And
Got it.
also, like, in many ways, developer experience is not just about how much you can get done. It's about making a meaningful impact. So
Mhm.
if you want to prevent quiet quitting, really focus on the middle pillar and the last pillar here. Optimize for creative work. Allow developers to make a meaningful impact, not just on your companies, but in the wider community.
Absolutely. No, that's, I think, a phenomenal insight because I think everyone that we talk to when it comes to getting people on board, it's always about saying,
Yeah.
how do we make guys more productive, right? How do we get more outputs out of them? And
Yes.
and and sometimes you set up these, it is popularly called a feature factory, where you're just punching out features and developers look productive on paper, but the
Yeah.
software itself is not delivering the value it's supposed to. So
Yes,
that's
yeah, indeed. I mean, like, I think since you mentioned, right? So if you look at a lot of the metrics also, it's like, it's time to first commit, right? So look, the very a way we measure metrics, the very, the very nomenclature of metrics is around lead time, cycle time, deployment frequency. If you look at it, it's pretty aggressive. It's how
Yeah.
fast can you go, right? But I think,
Mhm.
what really matters eventually is like, are we delivering the right kind of value? So in fact, maybe I would say we should really flip the coin to say, it's not about like developer productivity or even team productivity, but it's about effectiveness. So I think, one of my colleagues, I think Keith Mann has published an interesting research paper on the intersection of responsiveness, which is measured by speed and agility, and stakeholder value, right? So, and we call it not just delivery cadence, but value delivery cadence. How much value are you delivering? So, it's the intersection of things like customer satisfaction, end user adoption of features, and so on, with responsiveness. It's that combination that matters.
Mhm, mhm. Yeah, no, absolutely, and I think very importantly put, and it's so phenomenal, right? You're saying that developers shouldn't always be seen as these factory workers, productive
Yeah.
factory workers, the creative folks, right? Like art, almost artists that are creating
Yes.
amazing technologies, amazing experiences in their product, or whatever software they're building out. That the way we should approach and target their goals and productivity is very different, and the optimization shouldn't just be about these are the platforms you should use and these are the KPIs we measure you by, but how do we make them creative and how do we make them do really meaningful work, which would
Yeah.
also solve that key challenge, right? That uh,
Yeah.
how do you solve for quiet quitting and people just getting disenchanted with the whole developer experience and with the company? So that's spot on over there, absolutely. So in your opinion, Manjunath, what have you seen are those top key areas that companies that are facing these challenges, right? They're looking at saying that, okay, they're not giving the right developer experience. They're not building out the tech. It's
Yeah.
there at the top. Everyone knows what's to be
Yeah.
built out, but it doesn't translate into the actual value or the end experience that maybe a Google or a Slack can provide you. So,
Ah,
what do you
nice.
think are those top trends that someone should look at or when it's
Sure.
building something?
Like, so, in addition to focusing on developer experience, right, the other one that I'll emphasize would be
Mhm.
something like, I mean, there's many things that come to mind, but one that you'll see here is this whole idea of an impact loop, right? Many
Mhm.
times, if you've looked at, what Microsoft publishes or other tech digital native companies publish, we talk about inner loops and outer loops, right? It's inner loop would be, let's say, for instance, when a developer actually is coding, debugging, testing within sort of their own individual confines, that is on their laptop. Outer loop
Mhm.
is really about continuous integration. What happens after they commit code into, let's say, a Git repository, up till the point it reaches a production environment. But I think what's
Mhm.
missed out, right, is like, you might also, and this was a profound insight for me, is like,
Okay.
do organizations consider an impact loop, right? And what's an
Mhm.
impact loop? Impact loop is essentially saying, like, from the time a developer joins, right, uh, from the time they start to onboard to the time they can actually make an impact, right?
Yeah.
That's what is called an impact loop. So an interesting insight is, yes, optimizing for inner loops and outer loops is important, but also
Mhm.
think about, like, to how quickly and how effectively you can create an impact loop for them. Because remember, in most cases when developers join an organization, they're very motivated. That's the
Yeah.
reason they join, right? And so
Yeah.
in many ways, I would say that it's up to management, to sort of sustain that motivation. And the
Correct.
more opportunities you can provide developers to make a meaningful impact, the better it is. I'll also mention another interesting one, because you asked about trends and what
Mhm.
distinguishes, like, some of these good companies, the leaders, so to speak, from the
Mhm.
others, is new emerging concepts like inner source, for instance, right? So if you
Okay.
look at, let's say, as you scale an organization, you'll find that there's developers working in different pockets, right? In many cases, that leads to redundancy. There's lots of duplication. One team does not know what the other team is doing, right? In many cases, like, if you think about it, they're all reinventing the wheel, right? And
Yeah.
inner
Yeah.
source is this whole idea about saying, like, how is the open source community able to drive innovation at such an agile pace, right? So on one hand, then they're able to be agile, but on the other hand, they're also able to fix bugs pretty quickly. They're able to build secure code, right? And I think, who was it? I think Linus Torvalds, right, in his famous
Yeah.
quote said, "If there are enough eyes on it, all bugs are shallow," right? And that's
Yeah.
that's a really interesting quote, because what it means is you got to expose like your core assets, intellectual property, across the organization. So I would say, like, one takeaway from even in this from this session, if it is, if you want to implement something, do try to experiment with the concept of inner source. Like, expose your repositories to many teams. That encourages, like, modularity, right? So you create modular code. People not only become consumers of your code, but they can also contribute back to your modules, right? So I think, that's that in many ways, like, creates that kind of open source ways of working, open source culture within an organization.
Got it, got it. And no, that's an amazing theme out there, right? Because you always see this open source world, right? No meetings or very few
Yeah,
meetings, decentralized teams across the world, no concept of onboarding, offboarding of
yeah.
developers, and
and,
they do
and, and
such
you might wonder,
phenomenal.
how does it even work, right? How do
Yeah,
people get stuff done?
absolutely. Yeah, like how does anything happen in the open
Yeah,
source? And yet they're able to beat like corporate teams that have all the resources and all the tools, and
yeah.
sometimes build software that's amazing. So, and that's such a phenomenal concept, right? Inner source, to look at your company internally and see your tools as an open source solution. Obviously, not exposing it to the world, but applying those same approaches
Yes.
in house, and saying, can you make the organization like that? It would
Yeah,
be
yeah.
a phenomenal thing to work
And
at.
in fact, it's if you I mean, folks on the line can also go to inner source. I think it's called, much like we have design patterns, right? The gang of four, the architectural patterns. There
Yeah.
are dedicated, architectural patterns for inner source. One of them, I think, is called the inner source portal pattern. So there is a GitHub repository that I think was one of the first ones was created by SAP, and then AWS also has their own. So many of these companies are actually creating an open source uh, portal pattern, like, they're creating essentially like open source code where you can create your own inner source portal. If you think about it, right, it's more about like gamification. So
Mm.
in many cases, you might have different teams, like in your own company, Abhinav, right? So you'll have different products, and there could be some common modules. And
Yep.
if you gamify it, where you say, like, hey, if you're building a common library, do you want to find out, like, how many others find it useful? Like, can you create stars, right? And so
Yep.
inner source actually gamifies it and gives developers the passion, saying, hey, this is my module, I created it, but there's so
Yeah.
many others actually using it, right? People take pride in the work they do when they see others using it. So
Yeah, absolutely. And just bringing that whole open source culture into your organizational world, right? It could be a
yeah.
phenomenal way of looking at just running a tech company or a tech startup.
Yes.
So I think that could be a
Yeah.
very cool trend that everyone can take away. I think definitely we're going to see a lot of people head off to see inner source portal pattern, and see approaches and they can apply right after this. Also, folks that have joined in, we have a good number in. You can also please go ahead and put any questions, comments that you have, or thoughts in the comment section. We'll air them off for everyone.
This one, right? I mean, I just put this slide up just to because we are talking about interesting trends here, and I feel quite passionate about some of these. Like, one of these trends that's coming up a lot, Abhinav, these days is how, like, if you look back 10 years or so, right, people started building for the cloud. So you almost
Yep.
saw this like mass momentum of deployment saying, hey, we are moving to the cloud, right? This cloud migration became a big thing. All of the
Yep.
new deployments are now like being considered. Yeah, we're deploying in the cloud. Abstracts away all of the infrastructure complexity, all of the good stuff. But
Yep.
a
Yep.
new interesting trend now for software engineering is now you're not just building for the cloud, but you're building in the cloud, right? So I think the
Okay.
whole idea that you have development environments themselves being decoupled from your physical laptops, from individual developer machines, and those development environments you can like exponentially scale as you move them to the cloud. And Abhinav, I know, like, even within Fluid AI, you have some exposure to this, right? Maybe you can share like what's your experience with cloud-based IDEs or browser-based IDEs.
Yeah, no, absolutely. I think this has been a big trend that we've seen is that essentially, I think a lot of times we used to, for a new dev, we used to set up their machines, so they would get a desktop machine from the office, right? So setting it up, then if you're writing in Python or Node.js, there's tons of integrations, you need tons of software that needs to be put up out there. And then, it used to take them incredibly a large amount of time. And then when we move to a cloud-based IDE system, developers are able to spawn up workspaces and start working within minutes, right? Like you
Yeah.
join within a minute, your workspace is up, and your workspace goes bad or your Linux box, you mess it up, let's say, which always tends to happen when you're fooling around. You just spawn a new workspace and you're good to go.
Yeah.
So it's the power is phenomenal, absolutely, and it's become a
And I mean,
big
you
trend.
no longer have this problem of somebody saying, "Oh, well, it works on my machine," right? So this whole
Mhm.
idea of it works on my machine goes away, like, because
Mhm.
everybody is dealing with a common environment. You can share environments. It's almost like you share web pages through URLs. You can actually
Yeah,
share a dev environment with somebody else.
yeah, yeah. No, absolutely, absolutely. That's a crazy one. And what have you been seeing? I know another one that we've been talking a lot about, and a lot of folks that before this webinar were very excited to hear more about is this whole concept of resilience engineering. Because you always see
Yeah,
engineering
yeah,
as a very different, very straightforward, activity.
yeah.
So would love to hear your thoughts on what that exactly is.
Yeah, sure. I'll maybe like I'll always like to make it visual, right? I'll maybe bring something relevant so that people can digest it. So this was
Okay.
a new concept that we introduced. So resilience engineering, in many ways, um, yes, you have product engineering, right? Which is about building products. Then you have
Yep.
platform engineering, which enables scaling of building multiple products, multiple product teams. You're talking
Mhm.
about building internal developer platforms. But then
Mhm.
on the resilience engineering side, because you bring it up, it's about what happens, after you've deployed your applications in production, right? And in fact, in many ways, it's also what happens before that. So resilience
Mhm.
engineering starts with architecting for resilience, Abhinav. That's what
Okay.
I've seen. So
Right.
in many of these, like, really well established, proven digital native companies, they're not
Mhm.
really looking at let's say resilience just as monitoring, right? People
Yeah.
tend to conflate resilience and reliability, saying, "Oh, let's buy an APM solution.
Yeah.
Let's look at metrics, right? Logs." And even if you
Yeah.
move to observability, right?
Yeah.
It's like, okay, we got logs, metrics, traces, we are all set, right? So it's a very sort of reactive way of looking at resilience. But
True.
instead, what you really can start doing is how I'll maybe draw a good analogy here, because people
Okay.
relate to the word DevSecOps, right? Very well.
Mm-hmm.
So
Mm-hmm.
you can think of like DevSecOps as integrating security into every phase of the development lifecycle, right?
Right.
That's how we think about DevSecOps. You might also want to think about reliability and resilience in those same terms. It's almost like if you want to make up, a term like DevRelOps, right? So you're actually integrating reliability and resilience into every
Okay.
phase of the development lifecycle, right? And so
Got
what
it.
that fundamentally does is that it shifts the burden of resilience from just operations teams to now
Mm-hmm.
saying, like, we got to architect for resilience, we got to architect for reliability right from the
Mm-hmm.
get-go, right? And so you're architecting for reliability, you're designing for it, you're coding for reliability. And when you start doing it, you start to think, of things like, for instance, observability driven development. Much like you have test driven development, resilience engineering actually rests upon like observability driven development. So as
Mm-hmm.
when a developer is actually coding, you can start to, I mean, increasingly we're seeing this, like, using SDKs like open telemetry, for instance. They
Okay.
want to understand, like, what happens once this code is in production. How can I understand the internal state of my own application just looking at, external observable behavior, right? That's what observability is all about. So
Yeah.
you can also think in terms of like distributed tracing. That's another, very interesting thing, because you get a macro view and a micro view. So overall, Abhinav, if you ask me, like what comprises resilience engineering, I would maybe point you to something like this. It's like a balanced diet, right? Where it's not just one thing, but everything from observability to chaos engineering to site reliability engineering, and also securing your supply chain. I know
Got it.
it was a long answer, but hopefully, we did justice.
Yeah, no, absolutely. And I think it's the way to go, right? Because I think the old approach was to just leave it at observability. It still is with a lot of organizations where you'll get a lot of logs knowing what's gone wrong, but
Yeah,
you shouldn't be at that state, right? It shouldn't be so late in the day that you're coming to know that the issues that are resting in your application, it shouldn't be happening in production for sure. So
yeah,
building the approach from that 360-degree perspective, and chaos engineering is all about, right, introducing those elements of chaos during code. So
yeah,
maybe I know a lot of folks would love to hear a little bit more about what chaos engineering, uh,
yeah.
more specifically within resilience engineering, what's that
Yeah,
all about?
that's see that's that's a really interesting question. So in simple words, right? If you think about chaos engineering, it's
Mm.
like proactively introducing chaos within our system so that we build confidence in our own systems that they can withstand failures in production, right? So chaos
Yeah.
engineering is sort of a discipline where you say
Mm.
that if, to what extent do we have confidence in our systems to withstand some kind of turbulence in production, right? That's the whole idea. Now,
Yeah.
in simplistic words, that's a mouthful, right, to understand. But I love one quote from Casey Rosenthal. Like I think he's the CEO of Verica, and they
Mhm.
call it continuous verification and not so much
Okay.
chaos engineering. And if
Right.
you want to understand, most people would think, well, we already do testing, right? We do different kinds of testing, like
Yeah.
test-driven development. We do acceptance testing, performance testing. Why do we
Yeah.
need
Yeah.
chaos engineering? So
Correct.
the way he brilliantly summarized was, if you look at the difference between testing and chaos experiments, is that tests actually do not generate new knowledge, right? So when you test, you're
Mm.
actually validating for existing proven knowledge. So it does not
Yeah.
generate new knowledge. With chaos experiments, what you end up gaining is that you generate fresh insight. Experiments generate new knowledge, but tests don't generate new knowledge. That's, I think, a key insight, right? When you look at something like chaos engineering. Also, for me, like the other insight which I got was, like in many cases, you might see organizations saying, yeah, we have disaster recovery in place, we have
Mm.
failover, right? We have all these things in place. But
Right.
many times there's two elements to this, right? One is to make sure that those failover mechanisms and disaster recovery mechanisms, even auto scaling, for instance, actually work, right? That's one aspect of this. But
Yeah.
the other aspect is that, does it really kick in when needed, right? That's the question. So what chaos
Mm.
engineering helps you achieve is that, one, not only do failover mechanisms work, but do they actually kick in?
Yeah, got it. And it's like it's beautiful, right? Because you're suddenly it looks like the application's working, and you purposely slow down a database request, or you slow down an
Yeah,
API call, and you introduce problems into the system, as opposed to just your traditional, automated test, and then let's take it to, unit test, automated test, and ship to production. It'll build, and I can imagine it building that next level application, right? No matter someone's logging
yeah,
from a really slow connection, or say the database blew up, and your application at the front end is just working amazingly well. So
yeah.
that's a phenomenal insight over there.
Also, like I mean, I can point the listeners on this call to a very interesting book, which is called Evolutionary Architecture. I think it's written by some of the thought leaders at ThoughtWorks. Okay, so
Okay.
I actually forget the actual title. Maybe it's called Building Evolutionary Architectures. In that specifically, there is a
Okay.
concept that applies well to chaos engineering. It's called architecture fitness functions. That I love that concept, because if you think about, like, what's behind fitness function, it's essentially saying that, left to its own devices, any software architecture sort of degrades, right? So you keep
Right.
coding, you accumulate technical debt, like, you will find that software just degrades. It's like, software entropy. Okay, it
Correct.
just
Correct.
degrades. Now, what fitness functions essentially does is saying that you create these kind of test functions that continuously verifies if a system aligns to the original architectural goals, right? So as
Mm.
an architect, you might say that a given function should have X millisecond of latency. Now this should be, what the response time is, and so on and on. So you can
Yeah.
create you can really carve out all of these architectural objectives. But what fitness functions does is that as part of continuous integration, you can actually
Okay.
bake in those fitness functions and run them as if they were like, unit tests. So you're continuously running fitness functions as part of every continuous integration to say,
Hmm.
like, is our system like adhering to the original architectural goals? What's our architectural fidelity, right? That's the
Okay.
core point.
Got it.
And so
Got it.
if it violates it, you don't deploy it, right?
Awesome. No, absolutely. And you look at all these large organizations, and sometimes people feel it's so easy to build uh, great software
Yeah,
and amazing software, but it's so much about a lot of all these things at the back that's going on, right? How do you
yeah,
kind of keep your architecture up to date? How do you keep your software super resilient for any situation? How do you engineer for creative developers? It's very different from what most people see as UI UX and a simple
yeah,
a great UI UX and just a decent enough backend, and you could have the next Figma or the next uh, you know LinkedIn or
yeah.
Canva on ground. It's a lot more needs to be thought through and brought into the process that
Yeah.
actually enables a lot of it to actually happen.
I mean, to your point, I mean, I'll just make one small comment, right? And
Yeah.
see if we get any questions even from the audience. Is that like there was a very interesting sort of one survey response which we got. Like, have you thought about this? And maybe you have this feedback even from your own customer base, right? People
Yeah.
normally don't abandon applications because of some missing
That's
functional feature, right? And
true.
what we have seen is that it's the non-functional aspects of an application that cause customers to abandon apps, right? They just
Mm.
they move away from web pages, not because they don't like some content. It's always because it's slow. It's the non-functional aspects. I think one takeaway even from this our quick chat could be like focus on the non-functional aspects of system resilience, whether it is like scalability, performance, latency, or like the four golden signals of SRE, right? Latency, error rates, traffic, saturation, all of that,
Yeah. Yeah.
rather
Yeah.
than just focusing on feature functionality.
It's a phenomenal takeaway right there, right? I think, and if you look at all these platforms, right, like Google itself, not a lot has changed from the core search experience, but that core
Yeah,
experience is just become better and better and better. And
yeah,
I know they follow this 100 millisecond rule, right? Since you talked about response times,
mhm,
at Google there's a 100 millisecond rule because they say that below 100 milliseconds, if something like click a button and it reacts within 100 milliseconds, the human eye cannot tell the difference. It looks
yeah,
exactly real time, right?
yeah,
Anything beyond that is you can see the delay, and
yeah.
and everything Google builds has to be like it has to be within 100 milliseconds.
Yeah,
Uh,
if
and
you ask me, right, if there was one thing I had realized at the beginning of my development career, which
Mhm.
I mean, I unfortunately did not realize, and very
Mhm.
recently I saw this statement where, I think
Okay.
I don't know if it's Google or some other company where they say reliability has become a key differentiator, right? So I
Yeah.
had never focused as much on reliability being a differentiator for a product. Like, I mean, can you imagine, like a decade ago, people would just focus on throwing features at the problem, right? So you would think that people value features more than anything else. But now, if you look at these giant cloud companies and digital natives, for them
Mhm.
it's like reliability and resilience, which
Yeah.
actually differentiates them from the competition.
Absolutely. And that's I think a phenomenal takeaway for the folks listening in, that you don't need to always just think about all the features and adding as many features, but sometimes if you can know the core problem that you're solving for and work towards solving for that core problem
Yeah,
and just make it better, make it amazing, make that one experience phenomenal. That's a big part of building great software engineering.
Yeah.
when you actually build software.
You know,
We
there's
have
a
like
there's
no,
one
go ahead.
question, right? Abhinav, did you see that? I think Prashant or I think is asking a really good one, which is
Yes,
like, what's
yes,
the best way to maintain scalability without compromising maintainability? I
yes,
think that's a really good one. Do we want to tackle that? Yeah.
yes, yes. I was just gonna go to that one itself. So it looked like a
Yeah.
phenomenal question. So
Yeah.
go
Uh,
for it.
it's an interesting one. So how do you maintain scalability without compromising maintainability? I know at the heart of it, is essentially what Prashant is alluding to is, this is what we refer to as fragile architecture. As you sort of like what we mentioned, right? Left to itself, architecture usually degrades. There's technical debt accumulating, and in many
Mhm.
cases, your code is no longer maintainable, but you still want to scale it. There's many ideas coming to mind, so I'll just maybe throw out a few ideas, because when we get to
Absolutely.
specific of the implementation, we can find out what's the real problem in a given context. But
True.
overall, many ideas here could be: one, try to aim for as much statelessness as possible. So
Okay.
what's the best way to maintain scalability is, the more you can design your systems to be horizontally scalable and to be stateless, the more you can scale systems without affecting maintainability. In fact, there's a very sort of subtle benefit to designing stateless and a horizontally scalable system, is that implicitly they end up also being very modular, right? And so
Mm.
the more modular it is, the more maintainable it is. So that's one core idea. So designing for statelessness and horizontal scalability. The other idea that comes to mind on maintaining scalability is like what I mentioned around architectural fitness functions. Do continuously use that even when you're architecting a system. In addition to just writing unit tests for or acceptance tests for functional validation, also write fitness functions to test for scalability, to test if your system is as scalable as you had originally designed it, right?
Mm.
That's the second idea. The other one I'll also mention is maintaining scalability is, think of, let's say, for instance, you know uh, the whole, like, if you've read some of Sam Newman's books, right, on moving from monolithic to microservices architectures, right? So
Yeah.
that's, I think, a really good read. And how you can maintain scalability without compromising maintainability is, if you can, like, by the way, when we talk of microservices, people think it's like flipping a switch, but it's
Mm.
really not. You don't move from monolith to just
Overnight.
microservices by flipping a switch. It's like turning a dial, right? It's a spectrum. So
Yeah.
uh, you move, like, from monolith, there's the strangler pattern, the strangler fic pattern, which is very popular, right? You extract some systems that change often into its own modules, and then you start to scale those pieces. So which means, like, as we say, code that changes together stays together. Use that principle, and
Mm.
then essentially, that's how you get to build scalable systems.
Awesome. That's a fantastic answer to that. And as a quick segue, just opening it up, Raghav, I think I wanted to come in, and I'm just going to give him the floor.
Hi, Manjunath. It's been a great discussion that you've been having with Abhinav, and wonderful to see you today. I think one of the questions that I sort of had was that security has always been a key sort of thing that developers are looking at, and
Yeah.
now with this whole microservices and API ability, where you're heavily dependent, right? You're always calling some other, and it's in that kind of, that's where we're seeing a lot of these blockchain hacks, right? Wherein you're sort of dependent on somebody else, and then in that pass of the token, etc., your
Yeah.
security is compromised. So how should developers look at that, and how should engineering teams sort of look at, a lot of the security is not dependent on third parties or the way they integrate with third party applications.
Oh, that's a really good one. Like, in fact, I don't know if we had. I'll maybe bring up. We had this as part of digital immunity. Yeah, let's see if you can see this slide, right? I think this is our framework. This was my pet project. So I published this research, I think, in mid of last year. It was around the time, like in the aftermath of solar winds, and when supply chain security risks started to become very rampant, right? And so lots of attacks like even code cow, for instance. Like I know our recommendation is that you can't like buy your way out of this problem. I mean, in many ways you can't say I'll buy this security solution and magically all my supply chain security issues are fixed. That's never going to happen. No single vendor, no single solution, no one practice is going to fix it. So the way we like to see this is like, think of this along a three prong take a three pronged approach. One is fundamentally saying, like, how can we address the risks pertaining to code? So you're essentially tackling and attacking the code as a vector. That is both internally built code as well as external dependencies, code dependencies, right? So you're looking at, let's say, for internally built code, the classics things like SAST, static application security testing, dynamic testing, all of that, right? Even now these days, semantic code analysis, like for instance, GitHub has got SEML. Sonatype made an acquisition called MuseDev. There's this Snyk has got Deep Code. So there's this move from static code analysis to semantic code analysis. So all of that is for like internal code. But for external code, like you mentioned, Raghav, what you've got to do is now, instead of like having developers just arbitrarily download open source software from the internet, provide approved catalogs. That's a recommended approach, right? So you create, like, much like inner source portal patterns. So create an approved or curated catalog of open source, where you provide what we call a trusted component registry, right? In the second bullet of the first pillar that you see, that's a proven pattern where you can enforce secure external code, right? So this is, by the way, all about protecting at a code level. Then you start to look at, how do you build tamper-proof build pipelines? So you then move from saying like one trust boundary is code, move to the other trust boundary, which is your build pipelines, right? So there you implement things like secret scanning, secrets management. Also, like, even for instance, one of my favorites is JFrog came out with this interesting concept called signed pipelines, right? So is what you build exactly what you deploy, right? What you build should be what you deploy, and what you scan should be what you build, right? So it's this like traceability and provenance and integrity built into your build pipelines. So that's important. That's the central piece. And the last one, is like governance and access controls, right? Things like, for instance, insider attacks. How do you ensure that the right people have the right level of access, and everything to do with developer access and operating environment. Also, like, third party application access, to GitHubs, because these days everything is a marketplace. So we have to be careful on who has access and what has access. Things like machine identity management and so on. Awesome. I know we are maybe running out of time. I want to be respectful of people's time as well, but I hope we did justice to this question.
Yeah, no, absolutely.
I think the approved catalogs was a really strong point. I think that's something that's been missed till now.
Yeah.
Phenomenal. So Manjunath, just want to check. I know you also have a busy schedule. So do you have time for one more question, or should we wrap up? I'll leave that choice up to you.
We can take one more question for sure.
Okay. So we'll take Funny's question, and the team has brought it up on screen. So it's very interesting. He's talking about how do we strike a balance between a self-sustained development team, right, which is handling end-to-end of the cycle, versus a split approach, which I know a lot of the the big system integrator players, they'll always go with this separate approach. There's a dev team, there's a test team, and I know a lot of product teams look at it as, okay, it's one person taking it through the chain. So what's your thought?
I mean, this is there's no silver bullet to this, and it's a great question. Striking a balance, self-sustainable development team. I think what Funny is also referring to is like product teams, right? Product engineering teams. This whole shift to saying, are we this? What would Amazon call it? Like, two pizza teams, right? One team that does end-to-end delivery, right? So there is obviously that, and there is this, a separate development and testing team. I feel, the wind is blowing towards self-sustainable development team. So this is not like essentially to say the reason, and I'll also be very explicit. Why is it the case, right? It's the case because you don't want quality to become somebody else's problem. that is at the heart of it, Abhinav. So the
Yeah.
reason we say like don't have separate teams for development and testing is because fundamentally, what we mean by that is that quality is not a developer's problem, it's somebody else's problem, right? And
True.
that's not healthy for an organization. That's
Yeah.
why we say like, it should be one product team's responsibility owning everything from development to quality, even post deployment, right? So that's one aspect, one way to answer that question. The other insight I'll also provide to Funny would be based on our own research, and I can share this even after this call, is we found that the the way you can tackle this is to minimize dependencies between teams, right? It's actually pretty counterintuitive if you think about it. Like on one hand, right, Abhinav, we say facilitate foster collaboration between teams, right?
Yeah. Yeah.
But on the other hand, we also say minimize dependencies between teams. You see this paradox, right? Right, which is
Yeah.
like you want collaboration between teams, but you know that too much dependencies between teams can cause friction, can cause wait times, it can delay stuff. So I think a nice way to strike a balance is where you can minimize dependencies that teams wait on other teams to deliver stuff. So,
Awesome. No, and absolutely. It's almost like saying talk to each other because you want to, not because you have to, right?
that's a
Like
good one. Yes.
collaborate
Yeah.
and
Yeah.
interact, but not because you're forced to, because the other teams
Yeah.
are they're too
Yeah.
interdependent on knowing the
Yeah.
knowledge.
Yeah.
And absolutely. Awesome. This has been a phenomenal session, and I know we're getting some great comments in, and we're getting a lot of questions in as well, which we unfortunately I think have run out of time to cover. I'll leave this one last question. We want spend time on it, but any agile tools, maybe in one sentence answer, Manjunath, before we let you go. I know Dhanu's asked a great question on any agile tools for a team of six to be able to try, like top of mind tools that you feel they should definitely try, because what we talk about is quite extensive. So how do you make a team of
Yeah.
six actually leverage some of this?
How do we enable all these with an agile team of six, right? So I think, at what Dhanu is referring to is saying, yeah, if you have a very small team and you have so many things to consider,
Yeah.
how do we strike a balance? Even within a team of six, I'll maybe keep this short to say, doesn't matter, right? How big the team is, or how small the team is. By the way, an interesting insight here, a team of six, right? This reminds me, have you heard of this app called it's a popular social media app called Gas in the United States, and it's
Okay.
it's giving Facebook a run for its money, right? So which is, Gas is such a popular app, and the reason I mentioned that is because that team is less than six, so it's hugely
Oh,
popular app, and the entire app is built by a team of less than six people. So what
wow.
that means is that within a team of six, you might want to say, definitely, Dhanu, dedicate uh, one person for non-functional aspects of your application, another person for, like, the platform or the plumbing pieces, like build pipelines, right? The platform engineering stuff, right? So that could be another person. So we say performance and reliability is one person's responsibility, another person focused on security, a third person focused on platforms and build and all of that, and the remaining can focus on, like, functional development. I'm just like, this is really top of mind, so take it with a grain of salt, but all I'm saying here is, like, don't have everybody do everything. That's not going to help. Like, we can wrap up with this comment, right? When it's everybody's problem, it's nobody's problem, right?
Yeah,
So
absolutely.
so make sure that people are accountable for some specific things, and they would love that as well.
Awesome. I know we've run way over time, but the session was so interesting, and the knowledge you were throwing out there was phenomenal. I mean, I've got so many things to go and further enhance either in our organization, because we're doing a lot of these things that you were mentioning, but also think about from a future perspective. I think we've given tons of juice to all the folks on the call to go back into their organizations and see what they can take up next within the organization. So it's
Sure.
been an absolute pleasure, Manjunath, and I think it was phenomenal. I think everything that you shared with us, you were so candid, and it was so lovely. So we
Yeah.
look forward to hopefully having you again soon. But a big thank you from the entire team and all the folks that are hearing you live on this today, a very, very big thank you.
Yeah, and thanks from my end as well. I know it's Friday evening, so I know it's probably taken a lot of courage to just join to and to listen to a technical session like this on a Friday evening, right? So thanks to everyone on the call.
Awesome. All right. Thank you, everyone. Bye from all of us. Folks, just throw us some love on LinkedIn. You can follow Manjunath, you can follow me, Abhinav and Raghav as well. If you have any questions, do go ahead and follow Manjunath as well. If you have any questions, super, super excited and happy to have everyone. So stay tuned. We'll be having a lot of these series over the next couple of months. And keep listening, keep watching, keep learning, and keep growing. Thank you, everyone. Bye.